Hello, Algebra 2 class. Finally, we are podcasting. This is your homework for Sunday night to watch. This podcast is probably two, could be three, I hope not. No nice way to say it. I'm disappointed with the test results. I feel like we've had a lot of fun in class, but not enough attention to detail. So finally, with the podcast back in order, I am going to teach the lesson right now, which won't take very long. And we'll use class time tomorrow to actually practice. So bring your game tomorrow. First thing I want to do is go over a couple of the homework problems because I expect to get a question or two about those. This is from your lesson 1.5 practice sheet. Okay, directions here say use this formula equals BH for the area of the parallelogram and solve the missing variable. So if I was doing number 8 here, I know A is equal to 23 times 15. Now both of these are in centimeters. I'm going to do 23 times 15, and I'm going to get 345. Now this has to be in square units. Okay, so 345 centimeters squared. If you wrote SQCM, that's fine too. All right, so basically, like I said in class last week, algebra is if they give you a formula with a bunch of variables in it and they give you all but one, you should always be able to save for the missing one. If I have one like this where I know the area, and that's in meters squared, and I know the base, which is 25, now I'm solving for h. I'm just going to divide both sides by 25. Now notice, if this is in centimeters squared and this is in centimeters, I'm dividing out one of those centimeters. So I'm going to get 7 centimeters, because centimeters squared was divided by centimeters, and that canceled one of them out. So that's got to be the height. Okay, moving along. All right, this is the other thing. This goes back to what we actually did in class. We'll just grab, well, let's say number 12 here, okay? The change in x is plus 1, all right, all the time. So all these are plus 1. So this is going to be my slope, right? The change in y over the change in x, and the change in x is 1. Down here, it looks like we're going down by 7 every time. Okay, so we have to write an equation that represents the table. I know that I can take a y equals, the slope is going to be negative 7 divided by 1. I got there to the right. X plus the y-intercept. And remember we said that is the value of y when x is 0, right there. So it's got to be 89. Plus 89, game over. All right. If you haven't done them, do these other three. Make sure you know how to do this. And there's also a podcast on how to put an equation in and and look at the table, and you can make sure you got it right. All right, for section 1.6, to this email I have attached sheets that have the practice problems I'm about to show you. All right, we're going to do linear equalities. It's just like the equations we've done except for one situation. And the one situation is if I multiply or divide both sides of the equation by a negative number. Okay, so we're going to have some practice problems. You should print this out while you watch, and you can pause and do the problems that I'm putting in front of you. All right, in case you don't remember, the definition of an equation was it's a math sentence that says two things are equal. A linear inequality simply says two things are not equal, but it gives you more information than that. It can say that they're greater than. It can say that they're less than or equal to. It can say that they're less than. It can say that they're greater than, equal to. All right, and we know what this means. Compound inequality just means we're going to put two together, and equivalent inequalities, that's not a practical thing for you to know. Basically, that just means every time I do inverse operations, both sides of the inequality stay the same. All right, so moving on here. First example is you got to know when to use an open dot, which you use when your inequality sign does not have a line, does not say. So this is greater than, so I use an open dot. If I have an inequality with a line under it, so this says x is less than or equal to 4, then I use a solid dot. So that's just a fact you have to memorize. Greater than, less than, equal to, I'm going to use a solid dot. Less than or greater than, without the line, open dot. All right, you got two practices right down here. You should be able to graph these effectively. Watch the second podcast.